Osgoodian rendition of Krugerian triumph.
Krugerian inspiration
Yeah.
of
Yeah. Osgoodian rendition of Krugerian opus. Okay, so great. I can rename it on YouTube after I upload it. So, ladies and gentlemen, having done that, let's elaborate this model a little bit. First of all, I would like to draw your attention to the fact that right now, the contact rate is being specified in a hard-coded fashion as 1 per day. Suppose we want to vary that by different experiments, or, equally much so, the recovery time is set to be 3 days here. Suppose we want to be able to change the assumptions about that. We don't want to really go in and muck with the model in all its details. Rather, we would like to be able to specify in a neat way, a modular fashion on a experiment by experiment basis what to assume here. So in short, what do we need to put in to be able to capture this in a general way? Instead of hard coding 3, we want to be able to vary that by experiments. What do we need to do? Put in a parameter. Indeed. Now, if we want to vary it on a per experiment basis, not per person basis, but a per experiment basis, where does that parameter, where's it most natural for that parameter to live?
Main.
In main, indeed. We could put the parameter in person, but main's going to need to tell the person what to assume for them. So main would need a parameter also in order to vary by the experiment. So we might as well have the parameter for this be in main. So let's go up, let's go down main, and let's put in 2 parameters, okay? And I'm going to use this to show, as I am wont, I'm going to use it to show several features, okay? So here, we're going to have one parameter which is going to be infection duration. Infection duration in days. It's often nice to kind of say that. But why don't we just say infection duration? Okay, infection duration. Well, we'll come back to why I said that. Because we no longer need to hard code what unit it's in. Okay, infection duration. And secondly, we want to have contact rate. Okay? People per day, contact. Okay? So, ladies and gentlemen, infection duration. If we did this yesterday, I would have just said it's a double. But what could we use, instead of just saying a double, what could we say to good effect here? That it's a what? It's tempting to, I'm looking at contact rate here. That may be confusing to people. Infection duration. So what sort of thing? You could say maybe it's a length, but length is spatial length. So it's a what? Time. Indeed. And so we're going to be able to now specify units of our choosing, what it is. Now we're going to specify a default value of 3 days. That's just the value of, if the experiment doesn't fill it in manually, that's the value it will hold. And often that's the baseline value. That's the value we assume for the baseline by default. Okay, so that's for infection duration. How about contact rate? What sort of thing is that? A rate, indeed. And this will be a rate per day, we'll say, okay? A rate of 1, right now we have. Okay, now ladies and gentlemen, the beauty of this is that now each experiment is now going to be able to specify a contact rate in their own units. They could change it to 10 per week, for example, if they wanted to. And similarly, in infection duration, they could say 1 week of infection duration or 1 month. They could choose their own units. Do you see what I'm saying? Okay, so we're going to be able to specify that on a per experiment basis, which is indeed sweet. Okay, But we still haven't finished the job because we've added these parameters, okay? We've added these parameters in. Now we need to go refer to them. From where do we refer to them?
In person?
In person, indeed. So for the contact rate, it needs to be referred to here. Now, here's the rub, okay? This is the thing I want to teach you. Instead of saying 1 per day for the contact rate, we'd like to make it what? Contact rate. But now that contact rate, if we say contact rate here, AnyLogic will not be pleased. It'll say, I don't know what contact rate you mean. Instead, we need to say, hey, it's in main. Go look in main. So you need to say main.contact rate. It's the contact rate in main. Okay? Okay? And similarly, ladies and gentlemen, for this one here, for the duration of infection, I'm going to call this the recovery transition here. I'm going to make it be a timeout that depends on main.infection duration. Boom. Okay? And you'll notice that once again, we can specify for this, in what units it's to be specified. So what this allows us is it allows the user of this model to use units of convenience to them, which is very nice. Very nice. Okay? Okay. So, ladies and gentlemen, I'm going to build this model now, and you'll notice it says build completed successfully. So it's a happy camper. And we could then choose different units here for different, if we want to specify things in weeks versus days, etc. Okay, so that's something about the use of units here and the ability to encode assumptions which live in main, which only need to vary on per experiment basis, using parameters in main. Now, if these values differed on a per person basis, for example, based on a person's immunological status, we had their recovery rate, the time with infection be different, or their contact rate is different because they are, they're in one high-risk category or medium or low-risk category, we would actually probably be best having those parameters live in the person because they would vary per person. They would vary from one person to the next. But because they're only going to vary on a per experiment basis, we've put them in main, and hence we've had to refer to them as main.contact rate and main.infection duration. Does that make sense to you? Okay, ladies and gentlemen, thank you. Okay, so that's one thing I wanted to do. Another thing I wanted to do, ladies and gentlemen, was to go and put in place mechanisms for a model which will have an open population. And I'd like to do it on this model. Okay, we're going to build atop this model, this open population. Are you ready for this? Okay. So, ladies and gentlemen, let us proceed. Okay. So, I would like you now to go and we're going to put in place a change back to the original way we set people's location. We had kind of a hiatus where we set their location automatically by virtue of this layout type we used, but we're going to now go back and set that location by drawing from uniform distributions. Do you remember where we did that? Where did we do that? Whither do we go? It's in main, it's in population in particular. So if we go to population in main, remember this initial location? Remember that? Okay. Now, you'll notice this little light bulb. These light bulbs are extremely important in AnyLogic. there's a light bulb next to it that says, these settings are applied only if the user-defined layout type is set in the space and network properties. So this is warning us. So we need to go to main, scroll down to space and networks, and we need to set layout type to be user-defined. That's the only way it's going to listen to us. Is that okay? In main? So how did I do that? I went to main, I went down main, I went to space and network, and I set it to be a user-defined layout type. Are we okay? Okay. Okay. Great. Okay, now let's go back to the population, and now with that, with our confidence boosted, no, you notice now the little light bulb disappeared. Do you notice that? It's because we have our house in order now. So we'll just say in the specified point. And in my case, these things automatically reappear. They were hidden there, but now they're back. If you have to copy them manually, you can do so. Okay? So those things were just hidden. AnyLogic has this habit of doing that, and now they reappear. Are we ready to go? Okay, ladies and gentlemen, let's run the model now. Make sure it's all hunky-dory. Does the youngest generation use hunky-dory in the States?
I think half of the crowd is foreigners. So
I think Sean will be familiar with hunky-dory.
Oh, yeah. But
Yeah.
I don't classify as younger.
Yeah. Right. Okay. So we should have this this model running here in this sort of fashion. Do you see that? Okay. Okay. Who needs Krugerian help? Okay. 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 So, right. Okay. So the next step, ladies and gentlemen, having fixed that, if you don't need Krugerian help, the next step will be to go and add the elements of the open population in. So this is what I'd like you to do. I'd like you to go to main, and I'd like you to go add in an event. And this event will be called immigration event. Immigration event, okay? And this is going to go off at a certain rate, okay? It's going to go off at a rate. Therefore, the trigger type of the event will be a rate. What do I mean by a rate here? Can anyone remind me from yesterday?
Exponential distribution.
Yeah, it's an exponential distribution of the time between the events. It's a Poisson arrival. It's a Poisson process. So the time between events is independent and it's exponentially distributed. So it's independent of how long you've been waiting. The chance per unit time of having it happen, the next little time unit is the same. So it's a common, one of the most common stochastic processes, Poisson arrivals. Okay, so this will be a rate. It's a hazard rate, in short. And you'll notice we'll have a certain rate per day, but we should really have a parameter called immigration rate. Rather than hard coding that, we'll say immigration rate. Now, what sort of type will this be, this immigration rate? Can anyone say? What sort of type will that be? It'll be a rate, indeed. It'll be and we'll say by default it's per year, 100 people per year. Okay? Is that okay? Okay, ladies and gentlemen. Notice, by the way, the model's time unit. Does anyone remember what the time unit of the whole model was? It's in days. But we have the luxury of specifying our immigration more naturally is a per year rate, which is kind of more natural, right? Okay, so the immigration rate will be going off with this immigration rate. It's a per year immigration rate. And probably we should here make it clear, okay, the rate of the event is immigration rate per year. I would think it would convert that automatically, but I could be wrong. Okay, so per year immigration rate. Okay, so this is an immigration event. Now, this immigration event will fire over time. And in fact, I'm not asking you to do it, but if I were to run this, I would see, and I were to look where this event lies. It's actually right here. It's counting down the time to the next immigrant here. Counting down, counting down, counting down. There we go. 9, so on. As days pass by, the time to the next immigrant is going, and it's about to get it, and boom. Okay, and then it flipped, and then it's keep on going. Okay. But the job of an event, ladies and gentlemen, is to do something when it's triggered. It's triggering, but it's not doing anything. Okay? So now, this is where the rubber meets the road. This is where it's nitty-gritty. This is where the action's at, is to add the person to the population. May I show this to you? Okay. So, what I will do is I will say, now this is a little bit unusual. In fact, I rather disapprove of it, but they didn't ask my permission. Okay, ready? You will do add underbar population. If you have a population called pop, it'll be add underbar pop. Here it's add underbar population because the population is called population. If the population was called farm, you'd do add underbar farm. Or if it was called flock, you do add underbar flock. Okay? So it's whatever the population is. Now notice there's two options here. One is you don't give any information. And here it gives, here you have to specify for the person it's created their value of their parameters. In this case, we have a single parameter, whether or not they're initially infected. Okay? So here, I believe this one uses the default values of the parameters. This one we actually specify the parameter value. So, ladies and gentlemen, are you ready to do this? We're going to add in a person, and this person, we will add them in with a rate of infection that may be different from the population as a whole. So maybe this person coming in, for example, will have a random true, 80% or 50% chance of being infected. Okay, so here we're adding a person to the population, we're flipping a coin as to whether or not they are infected. Okay? And do we need a semicolon here or not? We do, because we're commanding it to do something. We're not just giving it a value. We're actually saying add this person to the population. Okay. Now, it would be better if we had a parameter called fraction of infection among immigrants. Okay. So we already have fraction initially infected. Well, let's add a parameter called fraction infected among immigrants. I'm tempted to say amongst, but among immigrants, okay? Okay, this is what I did. Okay. Okay, fraction infected among immigrants, okay? And that fraction infected by default, if we don't specify it, will be 50%, say. And here, in the immigration event, now we will do random true with what? So I did a fraction effect among immigrants. I set a default value of 50%. And in the immigration event, what will I do instead of this hard-coded 50% number? What will I put instead? Fraction infected among immigrants. Now, the virtue of that is, again, if I want to change it for different experiments, I don't have to go back and futz with the model. I just change it as an assumption associated with that experiment. Okay? So here we add someone in. Do you want to run this thing now? Can we run it? Okay, watch this. It's not going to be perfect, but it'll be getting there. And soon enough, we will have a very nice model. Okay, so what's happening over time? Can anyone see? Besides the infection occurring. What's happening over time? Oh my gosh. Oh my gosh. What's happening? There's now 70,000 people in the model, 81,000. Okay, let's stop it. Ready? Well, let's run this again. Can anyone see immigration occurring? Do you see it occurring? Who are the immigrants here? Whereupon do they live? Wherefore art thee? Huh? Do you see them coming in?
Yeah.
Okay, those are the immigrants coming in. What are they missing right now? Sorry? They're not connected. Okay, so ladies and gentlemen, may I show you something? May I show you how to knit them into a dynamic network so the network actually covers them? Can we do this? Okay. Okay, ladies and gentlemen, the good news is that for a distance-based network, it's straightforward. May we do this? Here we go. All you have to say is apply network. Do we need a semicolon? Indeed we do, because we're saying do this. It's not just computing a value. We're not just giving a value like a rate. Remember, this is apply network. If you may remember, if we just specify a rate, we don't need to have a semicolon. Let's go look at that when I make that statement. Well, let's go look at the event, right? Immigration event. I don't need a semicolon here to tell it what's the rate. Update histogram event. I don't need a semicolon for the first occurrence time. If I have person here, I don't need a semicolon for the contact rate, because it's just like a formula. It's computing a number. It's really when I order it to do something, ladies and gentlemen. When I say do this thing, then I need a semicolon, just like that. Does that make sense? Okay. Okay. Nonetheless, I apologize for the semicolons. Okay. Okay. So let's run this model. Now we have these people coming in, and you should see when people arrive, what's happening. Can anyone see it? When people arrive in, where are they being knit into the network? Do you see it? Do you see them coming in? Yeah, they're being knit into this network. The network is growing over time. Do you see that? Okay. Ladies and gentlemen, we've just added our first elements of an open population. But of course, another component of an open population is death or migration out migration, right? Okay, now, so we could pursue this in a couple of ways. So one way would be to go to person and to actually put in place a transition for death. Now, you notice I did something there that may have attracted your attention. you notice that I can make an area full screen by double clicking on this. And then I can view it without the encumbrance of other windows. And by double clicking on this again, I can get it back to a smaller size. So if I want to kind of zoom in conceptually, maybe it's on the properties pane, or maybe it's on the canvas. I want to see this, focus in on it for a while. I can do so. I can call up windows when I wish to. If I want to drag things in, for example, I can do so. I could go see the projects here, but I can keep in mind this this main element here. I can also do a restore of selective windows. So maybe I want to have the palette so I can drag things in, but I really want to see this. I don't want to look at the properties window now. But then when I'm done, double click and things come back to that layout. That's a useful trick. We okay with that? Okay, ladies and gentlemen. Okay, so we're a lot of the way through this. Open population. We've discovered the main thing. The hardest thing is adding someone in. Now let's add mortality transitions. Shall we do that? Okay, now I'm going to give this a little bit of a twist, as I am wont. Okay, so ladies and gentlemen, we're going to go to the state. Tempted to save this model just with immigration so we can see it built up, per Sean's comment, built up step by step. So I'm just going to save this, with immigration. So I'm going to say version 3 with immigration, and then I'll upload it, okay? And now I'm going to go on, and we're going to have with mortality, okay? Mortality. And probably by the same token, I should